All right, hello class. Uh, Excuse me. All right, hi class. For college prep math, hi. I hope you guys are doing well. For algebra two, uh, uh, glad you're continuing. We're gonna start off with some vocabulary at the beginning. Okay, so monomials. What are these? Okay, well you probably heard polynomial before. You've heard binomial, and monomial is just monomial is a number, a variable, or the product of numbers and variables. Another way of saying this is that it's just one term. This is oh, let's look at the root word first. Mono meaning one. If you ever set up your TV to be in mono, the sound to be in mono, you won't be able to differentiate whether the sound is coming from the left or coming from the right because, like whether you have two speakers or however many speakers you have, the sound is going to be coming. The same sound is going to be coming from everything, so you won't be able to tell whenever a sound is on the left or the right, whatever. Okay, but mono means one. Okay, here are some examples of what one term looks like. Okay, these are all monomials. Okay, so we have x, we have 3x, 5, it can be a constant, that's a constant right there. Xy, 3xy, or even 3x plus 5x. Okay, now the last one, you see, it's not really quite one term there, but whenever you simplify it, a 3x plus 5x, this is actually equal to 8x. Okay, so once you simplify that, that becomes a monomial. But I guess whenever you add them, it's two terms. You're adding up to two terms, but it's one term simplified. Okay, now let's look at this. Okay, so polynomials. Okay, a polynomial is a monomial. It could be one, or it could be the sum of monomials. Okay, so it could be multiple. Okay, the root word here is actually poly, meaning many. Okay, so whenever you hear polygon, that means many sides. Okay, polyhedron, that means many faces, and so on. Anytime you see the word poly, it means many. Okay, now, so here are some examples of some polynomials. We have x squared plus x plus 1, that has three terms. 3, you see, it can be one term. It's still a polynomial. 3x minus 2, that's two terms. That's also called a binomial, but we can still refer to it as a polynomial. X cubed plus 7, x power 6 plus 2x minus 7. These are all polynomials. Okay. All right. Oops. I don't know why that one's blank, but all right, let's keep on going. Okay, so a polynomial function is a function in this format. Okay, so f of x equals to a subscript n. So all these a's, the ones that are being highlighted, these are just all coefficients. Okay, so they have little subscripts, but that just is sort of to indicate the order. Okay, x to the power of n, we have x power n minus 1. These are all just exponents. Eventually you get to the point where you have no exponent, meaning that you have a 1 there. So I can write it down like this. Let me see. Let me change the color. Okay, so right here, this x, actually, it has an exponent of 1. And even though this a0 doesn't have an x variable, we can write it in. Okay, but a0 times x power 0, well, x power 0 is always going to be equal to 1. And a0 times 1, oops, excuse me, a0 times 1 is just a0. So that's why we don't write it down anymore. Okay, so basically you start off from an exponent of n, and eventually you get down to 0. You don't always need to have anything in between. Some of these values can be 0, but this first term at the beginning, this one right here, that one cannot be equal to 0. Okay, so actually let me change that color. So this one right here cannot be equal to 0. The exponents are all whole numbers, and your exponents, just in case you need me to point them out, are these. Okay, eventually they're all going to be whole numbers. 0 is a whole number, believe it or not. or it's an integer, sorry. Okay, an is called the leading coefficient. Let me go back to that. Leading coefficient. Okay, and let's look at that. Leading is the first person in line, right? The line leader. Okay, so the leading coefficient is going to be the first number in front of x. Whenever it's in the correct order, obviously. Okay, n is the degree of the polynomial. So this n right here, whatever it is, whatever the highest value is, that's going to be your degree of the polynomial. I'll talk about that a little bit more later. A0 is the constant term, so that's this part right here. Okay, so A0 is the constant term. This is usually just a number without an x next to it. Oops. Let me erase this part right here. Okay. Okay. So that could be a 3, it could be a 4, it could be a 5, it could be a 0, it could be a negative value. Okay. And then polynomial functions are in standard form whenever the degree of each term are in the order from highest to lowest. Okay. So what this means is that this one is always going to be the highest exponent. Okay. And then this one is going to be one lower, and then it's going to keep getting lower and lower and lower, and then eventually it's going to get to 1, and then eventually it's going to get to 0. Or just basically the x is non-existent. Okay. So here's some examples of polynomials in standard form. Okay. The degrees are over here on the left side. The types of functions are right here. The format for them are right here, and the examples for them are right here. Okay, so a polynomial of degree 0 is actually called a constant function. Okay, this just means that your function is equal to a value. Okay, not an x, not a variable, just a value. Okay, and it could be any value. It could be 5, 0, 3, whatever. Okay, it could be pi if you want it to be. The second type of function has a degree of 1, and it's called a linear function. Okay, so we worked with these before. They just make a straight line, a slanted straight line whenever you graph them. Okay, and actually, maybe I should draw something. Actually, never mind. Let's skip that part. Yeah, so this is what the linear functions look like. They have some sort of coefficient times x plus your constant value. Okay, so here we have 3x plus 5, and it could be any format of that. Okay, so you can exchange the values for different values. You can have minus 5 instead of plus 5. That minus is not going to affect it. You just want to make sure that whenever you start looking at A0, you treat it as a negative value instead of a positive. Okay, so just like we did with quadratic equations, where we chose our a, b, and c. Okay, a quadratic function has a degree of 2. This means that the biggest exponent on x is actually going to be equal to a 2. And this is what an example of it looks like. Okay, you can have less terms if you want. The equation could have been 6x squared plus 3x, and that would have still been a quadratic equation or quadratic function, and it would still have a degree of 2. The same thing happens for a cubic function, which has a degree of 3. Okay, so you see we have a coefficient right here. That first coefficient, remember, it cannot be equal to 0. Okay, this is your constant term, and constant terms can be 0. These can be 0, meaning that even a cubic function could be made from just one term. Okay, it doesn't have to be a bunch of them. It has to be at least one, and it has to have a degree of 3 on the. It has to have an exponent of 3 on the variable in order for it to qualify as a cubic function. Okay. Lastly, we have a quartic function, and we're going to be looking at other ones that are of higher degree. I just won't name them. Okay. So whenever I start working with x power 6, x power 5, x power 7, don't worry about the name, the type of function. I would really only recommend you start learning what all of these three are, because those are the most common. For the rest of them, we just start referring to their degree, by their degree. Okay. Okay. So this is for my algebra 2 students. So from this lesson, you are expected to be able to add, subtract, and multiply polynomials. Okay, this is what problems might look like. F of x plus g of x. That just means adding two polynomials. One of them is called f, one of them is called g. The second one is f of x minus g of x. The same thing, we're just subtracting polynomials or two functions together. And the last one, f of x times g of x, that's just multiplying polynomials or multiplying two functions together. Okay, but here we're only going to be working with polynomial functions, just like the ones we saw earlier in the table. Okay, so first we're going to go ahead and go add polynomials. Okay, so suppose we had these three polynomial functions. We have 13 minus 2x, 2x squared plus x minus 9, and x squared plus 3x plus 1. Let's look at what the first problem is. We have f of x plus g of x. Okay, so what does this mean? Okay, well, f of x refers to this equation right here. So I'm going to go ahead and write that down. 13 minus 2x. Okay, I'm going to put inside parentheses. That way I know that that's that first function right there. Okay, next we're going to add g of x. That means that we're going to add this equation right here. 2x squared plus x minus 9. Okay. What you want to do here is actually get rid of the parentheses if you're ever adding them. You actually don't really need them in this case. Whoops. Let me go ahead and erase them. Okay, and at this point the equation has not changed. If you're adding them, if you're subtracting them, that's a different story. Okay, so once you add them, you're going to go ahead and add the like terms. Okay, you're going to combine the like terms. We have 13 and minus 9 right here. Okay, those are like terms because they don't have an x next to them. Okay, minus 2x and plus x. Okay, and in case you're wondering, yes, right here in front of that x we can write down a 1. That way we don't forget that there is actually a 1 in front of that x. It's 1x. We just don't write it down all the time. And then finally we have plus 2x squared. Okay. All right, so 13 minus 9 is equal to 4. Negative 2x plus 1x is actually going to be minus 1x. We could write down minus 1x, or we could just write it down as minus x. It doesn't quite matter. And then plus 2x squared. Okay, and that's how you add those up. Okay, you can also put them in the correct, in standard form, I mean. Okay, standard form means that you're going to be writing down the highest exponent first, 2x squared. And then you write down the next highest exponent, which would be minus 1x. And then you write down the constant finally. So that's a positive 4, so I'm going to do plus 4. Okay, if it was a negative 4, I would write down minus 4. Okay, and that's your added polynomial. Let's go ahead and look at the next question. Okay, so we have h of x plus g of x. Okay, I'm going to change colors here to blue. And we're going to do the same exact thing. In this case, we have h of x, meaning that we're going to be looking at this equation, and then g of x, which means we're going to be looking at this equation again. So x squared plus 3x plus 1. I'm going to go ahead and put the parentheses on there again, and then add on to it g of x, which is 2x squared plus x minus 9. Okay, like I said before, we don't really need those parentheses, but I like writing them down anyways. Because whenever you're subtracting them, they do matter. Whenever you're not subtracting them, whenever you're just adding them, they don't quite matter as much. All right, so we have x squared plus 3x plus 1 plus 2x squared plus x minus 9. All right, so I'm going to add up the ones that look alike. X squared and 2x squared. I'm going to put a 1 in front of that x squared, this one right here, because, well, even though it's not written down, that's what it actually means. 2x squared right here, plus 3x from right there, and plus x right here. Again, you can write down 1x if you want to. You don't have to, but I think it might help you guys. And then plus 1 minus 9. Plus 1 minus 9. Okay, just combine the like terms. 1 plus 2 is equal to 3, so this is going to become 3x, well, not cubed, oops, not cubed, that is going to be a square. Okay, so 3x squared, let me change that color back to blue, 3x squared plus, and we have 3x plus 1x, that's going to become 4x. 3 plus 1 is 4, that's why I wrote down the 4. And then 1 minus 9, that's going to be negative 8. So this is going to be minus 8. Okay, if it was positive 8, then I would write down plus 8. Okay, and that's how you add polynomials. Okay, so it's not very hard. You're just adding the like terms. Just make sure that you know how to do that. And then don't mix them up. Okay, combine the x's with the x's, the x squareds with the x squareds, and the constants with the constants. Alright, next up is subtracting polynomials. Alright, so these are our equations now. This is going to be our first problem. Let me change back to black. F of x minus g of x. Okay, so we have 12x minus 5. Okay, that's that first equation. In this case, I am going to put the parentheses again. And we're going to do minus and then parentheses g of x. So that means x squared plus x minus 6. Oh, sorry. Okay, so before we start anything on here, I want you guys to pay attention to the negative. Okay, in this case, it's actually going to be distributed. Okay, the negative is going to go to the x squared, it's going to go to the x, and it's going to go to the negative 6. Meaning 12x minus 5, I'm going to remove the parentheses, is going to be subtracted an x squared. It's going to be subtracted an x, and then a negative times a negative becomes a positive, so it's going to be added a plus 6. Okay, we're going to combine the like terms. Okay, I'm going to start off with the highest degree term. That means the x squared. Because it's being subtracted away and there's nothing else, I'm just going to rewrite that again. Okay, so it becomes negative x squared. Negative 1x squared if you want to write it down. I just won't for now. Okay, next up is our x values. Oops, let me, whoops. How do I go back? Whatever. That was a 12, right? Okay, we're going to, I meant to highlight it. We're going to go ahead and add the x's together. Okay, so 12x minus x, that becomes plus 11x, because 12 minus 1 is 11. And it's positive, so it becomes plus. And then finally, our, let's see, I'll do it in red, I guess. Our constants, this minus 5 and this plus 6, we add them together. Minus 5 plus 6 is equal to positive 1. So it becomes plus 1. This is our final answer for that equation. It's already in the right order. It's nice to start off with the highest degree term first, meaning the one with the highest exponent. That way you can, you don't have to rewrite it at the very end. Next question, we have hx minus g of x. Okay, blue. H of x is, again, the one at the end, right here. 4x squared plus 5x plus 1. I'm going to put parentheses around it, and I'm going to subtract away the g of x. So minus x squared plus x minus 6, all inside of the parentheses. Okay, again, the negative is going to distribute. It's going to go to the x squared, it's going to go to the x, and it's going to go to, why did I put minus 6? Oh, right, yeah, never mind. Okay, so we have minus 6. Okay, I'm just going to rewrite the first few terms. 4x squared plus 5x plus 1. And I'm going to go ahead and distribute our negative. Minus x squared minus x plus 6. Yeah, and it's the same thing as before. We have 4x squared plus 5x plus 1, and minus x squared minus x plus 6. We're going to go ahead and combine the like terms, starting with the highest degree terms. Okay, that means that 4x squared and the negative x squared get added together. That's going to be 4 minus 1, so it becomes 3x squared. Okay, because remember, there's a 1 in front of there, even if you don't see it. Plus 5x and minus x, or minus 1x, becomes positive 4x, because 5 minus 1 is equal to 4. And then positive 1 plus 6 equals to 7. So positive 7. This is our final answer for adding the two polynomials. Okay. Remember that you can always pause and look back at this, because it's on YouTube. You can even play it a little bit slower if it's hard for you to follow along. Do this at your own pace, guys. Do not worry too much about trying to get this as fast as possible. You guys have time. Okay. If you have any questions, remember you can ask me questions on Remind. If you need me to explain something a little bit better in person, I can always video chat with you during school hours on Microsoft Teams as well. Okay. Next, finally, multiplying polynomials. Okay. So we have three polynomial functions. We're going to go ahead and multiply some of these. The first thing we're going to do is multiply f of x times g of x. Right. So f of x times g of x, this means 12 plus 3x. I'm going to put this inside parentheses. Okay, you all guys really want to do this. And times g of x, we're going to have 7x squared plus 5 over here. Okay, so this can be done multiple ways. We can do the box method. We can do FOIL method. We can use distributive property. But basically, you just want to make sure that you multiply these correctly. Okay. If you're going to be using the FOIL method, remember you're going to be multiplying the first terms for each equation, each set of parentheses together. That's going to be 12 times 7x squared. And then you're going to be multiplying the outer terms, which is 12 times 5. Then your inner terms, which is your 3x times 7x squared. And then your last terms, which is 3x times 5. Okay. Now, you can do it this way, or you could decide to do it the box method, which I think in most cases is a little bit easier for you guys to do. Okay. So we have 12 and 3x, 7x squared, and 5. We could write it down like that. And we just multiply the numbers first, and then multiply the variables. Okay, so we have 12 times 7, that's going to be 84. Since there's no x here, we don't change the x that's already there. Whoops. So it becomes 84x squared. Then we have, I'm going to move over to the right, top right corner. 7 times 3 is 21. X squared times x. Well, that's going to be 3x's, so that's going to be x cubed. Then we have 12 times 5, that's going to be 60. And finally, 3 times 5, which is 15. Since there's one x, we'll write it down. 15x. All right, so the highest term here is actually going to be that 21x cubed. So I'm going to write that down first. 21x cubed. Notice that it's positive, so that's why I leave it positive. The next term is 84 x squared. That's the next highest degree term. Okay, you see I'm looking at the exponents to write them down in the correct order, right here and right here. The next one would be 15x. Whoops. Plus 15x. And then plus 60 for that final constant term. Okay, so this is our final answer for multiplying the two terms, two-term polynomial equations, okay, or polynomial functions. But it's not always going to be that easy. Take a look at this. We have h of x times g of x. Notice what's different about h of x. Okay, I'll give you a few seconds to see if you can figure out what's different about that one, g of x, and f of x. Well, if you noticed, it actually has 3 terms. Okay, if that's what you said, good job. You know, you're a pretty smart kid. Yeah, you guys all are. Never mind. All right, so h of x is actually 3 terms. So you have x squared plus 3x plus 1. And we're going to multiply it times a 2-term equation, which was 7x squared plus 5. Okay, now you can do the exact same thing as with the FOIL, but you have more terms, so you actually have to multiply more numbers. Or you can use the box method again. Okay, for this one, I'd prefer you guys use the box method because it makes it a little less confusing. To multiply, then notice I made 6 boxes this time. This is because we have 3 terms for the first one, we have 2 terms for the second one. I'm going to go ahead and write those in at the top. X squared, 3x, and 1. On the left hand side, we have 7x squared and positive 5. We're just going to be multiplying the numbers out. It doesn't matter which boxes you start off with. If you want to start off with the 5s, you can. Just make sure that you fill them all in. 5 times x squared becomes 5x squared. 5 times 3x becomes 15x. 5 times 1 becomes 5. And then we do the same thing for the 7x squared. 7x squared times x squared becomes 7, because there is no other number, or you can think about it as a 1 right there. 7 times 1 is 7. X squared times x squared. Well, if there's 2 x's on this one, there's 2 x's on that one. There's 4 x's total. So that's going to be x to the power 4. 3 times 7 is 21. X squared times x becomes 3x's. So that's going to become x cubed, or x to the power 3. And then finally, 7x squared times 1. Well, anything multiplied times 1 stays the same. So this becomes 7x squared. Okay, now here's the thing here. If you notice, the value right here and the value right here share the same degree. Okay, this means that they are like terms. So you're going to have to add them up before anything else. But we're going to do that in the middle once we get to that term. Okay, first we're going to start off with the highest degree term, which is that 7x to the power 4. Okay, then we move on to the next highest. If we have to add any along the way, you add them then. X power of 3, that's the only x power of 3, so we leave it the same. So it's going to be plus 21x power of 3. Then we have the x squared variables, the terms. 7x squared plus 5x squared. 7 plus 5 is equal to 12. So that's actually going to become plus 12x squared. Okay. Because 7 plus 5 equals 12. Those green ones, that's where they went. Okay. Lastly, we have the next term, 15x. And then we have 5 as our constant. So our leading coefficient is 7. Our constant term is 5. Our degree is 4. Okay. So make sure that you know what degree your leading coefficient and your constant terms are. You want to make sure that you put them in the right places, because I will be asking questions about that later on. Not on this slide, but later on. Okay. So we have, I think, one more slide remaining. Let me check. Yeah, one more slide. So this is actually going to be your homework. I want you guys to go ahead and pause the video here, try to attempt these problems. Again, send it to me on Remind. You want to send me a picture of your work and your final answer. Make sure that it's visible so that I can see your answer. You can also send these to me through Microsoft Teams. Remember that you can get the app online on your phone or on your laptop. Okay. Well, I hope you guys enjoy your day, and if you want to like and subscribe, no, I'm just kidding. All right, you guys make the best out of this break that we unfortunately have to have. Stay safe. Make sure to wash your hands.